Hello, welcome to Edu Paragon TV. My name is Adeyemi, and I'm glad to join you again on another beautiful video talking about mathematics. Today, we are going to be talking about variation. As you know, we are on a series, and until we finish it, I don't want to go to another topic because I want you to be grounded in the knowledge of variation. So today we are going to be talking about specifically joint variation. Don't forget, we have done direct variation, we have done inverse variation, otherwise known as indirect. Today, we are going to be talking about joint variation. So let's get to the class. But before then, I would like you to like this video, subscribe to the channel, and turn on notification so that you can get more videos as this. So it's time to get to the class. Welcome to the class. So, like I told you, we are going to be talking about joint variation. Joint variation. So, let's get to understand what joint variation is talking about. This type of variation involves at least three variables. You have 1, 2, 3 variables involved in joint variation. If you don't want to call them variables, you can call them quantities. For example, the volume of a cylinder, let's call the volume V, varies directly as its height h, also as the square of its radius r. Now, symbolically, this is written as V is proportional to h times r squared. V is proportional to h times r squared. Now, it is important for us to note here that V is both directly proportional to h and r squared. Hence, you have h times r squared. It will not always be like this, and I will show you very soon. So, to simplify what you have here, you just simply say V is proportional to h r squared, or V is directly proportional to h r squared. Like I told you, it will not always be that the first quantity will be both proportional to the other two quantities. It could actually be one that is directly proportional and the other inversely proportional, or vice versa, as we are going to see in this next example of the definition I want to give you. If P is directly proportional to T and inversely proportional to V. Now you see here now that P, which is the first quantity, is first of all directly proportional to T, which is the second quantity, and inversely proportional to V, which is the third quantity. Mind you, it could be first inversely proportional before being directly proportional. So it could just be either way. I need to call your attention to this so that you don't get things mixed up. It means then that P is directly proportional to T and inversely proportional to V. And that's why you have P directly proportional to T times 1 over V. 1 over V being the inverse. Then you can simplify this expression by simply saying P is directly proportional to T over V. Is directly proportional to T over V. By just multiplying T and 1, then you just have T over V. So with this background, we are safe then to look at examples. So example 1, let's get to see the question. If P is directly proportional to X and the square of Y, and P is 1500 when X is equal to 10 and Y is equal to 150. So let's get to the details of the question. A, find the value of the constant of proportionality. Find the value of constant of proportionality, that is, find the value of K. So remember our K. Then B, find the relationship between Px and Y. Also, you will not forget the relationship, because variation is actually talking about relationship. And let's get to C. If Y is increased by 20%, find the new value of P. We will take this one by one in our solution. Like I always tell you, the first thing you will do here is to express your variation. And since the question says P is directly proportional to X and the square of Y, then you can just simply say P is proportional to X Y squared. Now the next thing is to introduce our K. So P is equal to Kx squared. For those of you just joining me in this video, I will leave a link below to the video that I have made that talks about direct variation. There you will get to see how this K comes around. All right, so simplifying the equation we have up here to find K, then we just simply say K is equal to P over X squared. Of course, again, in the previous video, I've explained how we arrive at this. So the next thing to do is just to substitute. P is equal to 1500 and X is equal to 10. Y squared is equal to 150 times 150, as we have been given in the question. You can use your calculator. Sorry about that. Let me bring back that slide. All right. So you can use your calculator to find K, and K will simply give you 1 over 150. So let's get to the big part of the question now. The relationship between Px and Y, and that is simply P is equal to 1 over 150 xy squared. Xy squared. So this is also explained in previous videos. Now let's get to C question. Y is increased by 20%. Y is increased by 20%. Then it then means that 20% of Y plus Y, because it is increased. 20% of Y plus Y, because Y is increased by 20%. So breaking that down, 20% of Y simply means 20 over 100 times 150. Y being 150 plus Y plus 150. Simplifying further, we have 30 plus 150. 20% of 150 is 30. So we just add that to 150. And we have Y is equal to 180. Now, having known this value, we can go ahead to substitute it in the relationship that we have, in the equation that we have, that is this equation, this relationship. So just substitute. So you have P is equal to 1 over 150 times 10, X being 10, as given to us in the question, then times 180 times 180, that is Y squared. Don't forget, we have found the new value of Y that we are to use to be 180. Now, using your calculator, you can simplify it further, and P is equal to 1160. With this, we have solved the first example. So let's simply try one more example before we go from the class. So example 2, let's see the question. The electrical resistance R of a piece of wire with a cross section is directly proportional to the length L and inversely proportional to the square of the radius R. So details of the question now. A, find the formula connecting the three variables. If A is 150, if a 150 length, let me take that question again. Find the formula connecting the three variables if a 150 mm length of wire of 25 mm radius is found to have a resistance of 40 ohms. Okay, then let's get to the big question. A question is talking about relationship. The big question, then find the length of the wire of the same radius that will have a resistance of 12 ohms. Solution. First thing, express the variation. R is proportional to L over R squared, because R is first of all directly proportional to L and inversely proportional to R squared, which is R is proportional to L over R squared. So we can introduce our K now. R is equal to KL over R squared. That is, big R is equal to KL over R squared, small r squared. So from the question, we just substitute the capital letter R is 4, the L is 50, then the radius is 25. So you have 4 is equal to K times 50 over 25 times 25. 25 times 25 representing R squared. So simplifying further, 4 is equal to 2K over 25. How did we arrive at that? 25 can divide 50. That will give you 2. So 4 times 2, K times 2 rather is 2K. Then 4 is equal to 2K over 25. 2K is equal to 4 times 25. How did you arrive at this? It's simply by multiplying both sides by 25. Multiplying 4 by 25 and multiplying 2K over 25 by 25. If you simplify that further, you have 2K is equal to 4 times 25. And that simply gives us K is equal to 4 times 25 over 2. We can simplify this further and it will give us K is equal to 50. 2 can divide 4. That will give you 2. 2 times 25, we have 50. So successfully we have found K. Then we need to express the relationship or the formula connecting RL and R. R, big R, L, and small letter r, that is the radius. And that will simply be R is equal to 50L over R squared. So we have solved the first part of the question. So let's get to the second part. So first of all, we write the relationship out. It's an equation, of course, it's the equation connecting the three variables. So then we now do substitution. K is 50 as we have found. L over R squared. So R is 12, the big R is 12, and the radius, small r, is 25. So just substitute. So you have 12 is equal to 50 times L over 25 times 25. Don't forget, it is the L that we are asked to find. So you have 12 is equal to 2L over 25. So L then we give, 2L then we give you 12 times 25. And simplifying further, you have L is equal to 25 times 12 times 25 over 2. 2 can divide 12 to give you 6. 6 times 25. will give us the value of L, which is 150 millimeters. So we have come to the end of the class. But before we go, check these activities, try them on your own, and you can always get back to me. Leave a comment in the comment box and I will attend to all your comments. Thank you very much. See you in the next video.